Forward. Yes, remember the critical step, share screen. Done. All right. I don't. Do I see now? You're going to make me pause the recording. Hang on a second. So yeah, our next little unit, which should not take long. We do this in other like Algebra 2, but we go to a much greater depth in Algebra 2. So for you guys, this should not be anything brutal at all. So our next little unit is on radicals. So, and by the way, since none of you knew what I was talking about, a radical is sort of a catch-all term for one of these. What's that called? Yeah, it's called a root. Very good. Good. So it's all coming back to you. So this is called in this particular case, the one that I've drawn is called a square root. There are also other types of roots, like this one, is called a cube root. This one is called a fourth root, and so on and so forth. But we primarily in intermediate algebra are going to focus on square roots. So good. So we're going to do 3 or 4 different things with radicals. The first one on the checklist is today we're going to learn something. I almost hate to even say this because you're going to think it's really hard. We're learning today to rationalize denominators, which that's a lot of syllables, but it's really not that bad at all. So before we run through the actual lesson and what we're doing, we're going to recap some old skills just to make sure that we don't hit roadblocks along the way. So a long time ago in this class, I had you guys simplifying radicals. So for example, let's say I put the square root of 8. We're not getting through today's lesson or the next couple of days if we don't remember how to do this. So do you remember how? Good job. So yeah, good job. That was real quick. You guys are crushing it. So remember how we kind of made trees? I think that was kind of our go-to method, and we broke it up into the root of 4 and the root of 2, right? And what's the square root of 4? So we broke this or simplified it, we would say, into 2 root 2. You're going to be needing this skill today. All right, let's practice another one. This is one of those, I think that when Miss Willoughby made our cheat sheet for us, we called these like the death numbers, remember? Do you guys remember 32? You guys are amazing. So root 16 and 2. Good job not saying the rookie thing and saying like 4 times 8. You guys are awesome. What's the square root of 16? 4. Is this all? I wasn't sure how long this part of the, huh? The which sheet? Oh, there's more. I don't have a lot left, but there's more. So do you guys, other than resources that perhaps you've misplaced, do you have any questions, or do you feel like this is something that I can move past? Okay, good. So the other skill that you have to have for today is how to reduce a fraction, and I feel like that you probably get that one since you've been doing it since grade school. So so here's what today's problems are going to look like, and this is a weird one because this is kind of one of those math for the sake of more math skills. You know what I mean? As is so much of what we teach you in high school. It's like, let's learn a skill that will enable us then to do more skills, right? And there comes a point, yes, where math gets applied to build things and save the human race and stuff like that. But for us today, we're just going to practice a skill. We're going to learn a skill. So this is the type of problem you're going to be doing today. And I'm going to write down here in a second off to the side what the name of today's lesson is, just so you're familiar. And I say, this shouldn't take long, but I've been wrong before about these things, so it's hard to say. So what you guys are doing is, this is called, you'll probably want to write this down. We're going to be rationalizing the denominator. And this is just one of these skills that you really shouldn't leave high school, because we don't know what you're going to do if you're going to take college math or whatever, but we're not doing our job if we send you out of here, whether it's LCCC or whatever. Hopefully not prison, Luke. Yeah. But this is a skill you should possess. All college math teachers would assume you know how to do this. So here's what the words mean. So the term to rationalize is to make something rational. And we don't talk a lot about this, but this is called An irrational number, right? You guys know there are some examples of irrational numbers. One of them is on the wall behind me. It's up there, and that's pi is an irrational number, right? E is another example of an irrational number. The most common irrational numbers, though, that we see are square roots of things that don't work. Square root of 10, the square root of 2, the square root of 5. Those are all irrational. Now, the square root of 9 is what? So that's a rational number, right? So to be an irrational number, you have to be an unrootable root, essentially. So our goal by saying I'm going to rationalize you is I'm going to turn him into something that's not bad. Good? You with me? Sammy? All right. So let's take a quick little detour here off to the side and talk fundamentals real quick. What would you guys say is the answer if I gave you the square root of 5 times the square root of 5? Yeah, I don't disagree with that at all. That's, having taught this for 2.5 decades, that's usually what people say first. Until we learn the shortcut, you said exactly the right thing. You're like, you give me a root, you ask me to multiply them, I'm just going to give you another root with the stuff inside multiplied together. And then you're like, hang on, what is the square root of 25? It's not even a breakdown. It's just the root of 25 is 5, straight up, right? Do you see maybe a shortcut we could have taken? Yes. So let's see. Let's put our skills to the test and see if we can skip that intermediary step. See if we can knock that guy out. What's the square root of 10 times another square root of 10? It is. What's the square root of anything? X times the square root of X. It is X. We could do this all day. So I think we've now covered all of the requisite skills, and it's time to just get in there and do this thing. Ready? All right. So what we have here is an expression with an irrational denominator, and our job is to make it rational. This is a skill, like I said, that anyone would expect you in the same way that they expect you to know how to reduce fractions or know your times tables. Yeah. I would, yes. Can you want to be more specific, Chance? I will, but I have to do something to make it happen. You're exactly right. So let's talk about you can't, by the way, great question. You can't reduce this right now because the 6 is in jail and the 4 is not. So they don't get to play together. So you can't reduce. Say that again, Sam. Yes, you do. So what we're all going to do is we're going to take the bottom of the fraction and we're going to multiply it by itself. Well spoken there, Sammy. But as you learned in, like, I don't know, 4th grade, if you multiply the bottom of a fraction by something, you have to do it identically to the top. Remember, if you don't want a fraction to actually lose its value, if you do something to the bottom, Brandon, put your phone away. If you do something to the, oh, is that a calculator? Oh, my bad, buddy. What's with them making these calculators look like phones? Kids these days, if you multiply the bottom, you have to do exactly the same thing to the top, or the fraction doesn't equal the same thing. No, because if I do 4 times 4, I could, but it wouldn't serve any purpose. Let me ask you a really important question right now. What immensely important purpose does that gold box? And isn't that what we're after? Don't worry about the top. You worry about the bottom. So whatever you have to do to the bottom, copy it to the top. Clear? All right. Clear as mud. Thanks, Colby. I appreciate that. So what do we get on top? It's very unexciting. You get 4 root 6. Sorry, there's just no meat on that bone, right? But what do we get on bottom? You guys are good. And then the final step in this process, as I said earlier, is you got to know. It's not the same problem. It's like, I kind of want to throw something at you, but no, it's not the same problem. That would be like a kid who's learning how to reduce fractions, reducing a fraction and saying, well, isn't it the same problem? Listen, what we're going to get in a second is the final answer, and it's the same value of a fraction, but it's mathematically acceptable. In the same way that, like, your 4th grade teacher taught you that, okay, students, if you have a pizza with 8 slices, and you eat 4, that's the same as a 1/2 of the pizza, right? Do they look different? Yes. Do they mean the same thing? Yes. But math people all around the world know that this is the one that we want, right? And it's not going to be, quote, the same thing, Dallas. So do y'all see that there's now a little fraction right here? I'm going to make a red box for you that you can reduce. What do those both reduce down to? Good. So our final answer is 2 roots of 6 over 3. And no, it's not the same. It equals the same thing, though. Let's go again. All right. So were you still writing, bro? Final answers in this blue box, Kale. Big primo right there.
Yeah, but that's the same.
Yes, yes, good. Thank you, Kale. Perhaps I should be more clear. The blue boxes equal each other. Yes. But the one on the right, the one with the star next to it, is the one that math people all over the world would say, oh, that's acceptable. The other one is not, right? So let's go again. Say again. I almost wrote the wrong thing. Let's do 3 over root 3. So these ones should start to go a little bit quicker for us. What do we do to this one?
Multiply
by root 3. Good. So whatever you find on the bottom, basically duplicate it, multiply it, but then duplicate that process to the top. So we also multiply by root 3. What do we get on top? 3 root 3, I heard, over. And then can we reduce? You could, and I wouldn't even put the 1. Nice job, you guys. You crushed that one. Slated. Because, yeah, these 3s, Kale, you see how these 3s right here are going to reduce down? 3 divided by 3. Are you with me?
So to get
okay, let's keep.
To get 3 root 3 on the top, it's kind of like
It's literally just taking those two things and essentially just super gluing them together. Yeah, there's very little math to do there. The only real no, isn't that good news? I mean, no. Nice try. No, this is it like for, today. So let's do another one. Let's do 6 over the square root of 7. You're just learning a skill today. You're learning a skill that you'll carry with you and will be asked to use in certain instances. So we're going to multiply the top and the bottom. What am I multiplying by? Good job. And remember, whatever you do to the bottom, you do to the top. What do we get on top? Nice job, Mikhail. 6 root 7 over. And can we reduce the free guys? Done. Now, I have a couple more examples, and when I wrote these down, I wasn't sure whether you'd ask a certain question or not. So I'm going to put this next. I've got at least a couple more, and I'll be curious to see if you asked the question that I wasn't sure you would. So our next one is going to be 6 over the square root of 28. And again, I'm coming along for the ride here, so you can determine how the next couple minutes go. Yeah, I'm gonna pause. Maybe I won't pause the recording. There's gonna be a huge problem, and I struggle philosophically, and I always have, and I will never know the answer to this. I'm within 5 to 10 years from retirement, and I'll never know what's the right answer to this. But I've got several students whose calculators, you just type them in and they do them. I struggle with, as I always have, like at what point does technology become, does it go from being useful to causing us to be mathematically illiterate? And I want you to know that any debate you want to have with me about this, I'll have with you, but just know that I don't really have a perfect answer. But here's what I know. If you're typing these into one of those Casios that just simplifies it, I don't want your input because, sorry, that sounds rude, but I want us to learn this process. I don't want us to learn how to hit numbers and hit enter and have it do it for us. So some calculators have a certain mode. It's called math input output that will do this. I'm not interested in any of that today. Do you understand that, right? You know me well enough to know that that's how I roll. So again, is there something to be said for why do it if my calculator will do it? I'm the kind of guy that will struggle with that question until I'm done teaching. And I don't know what the answer is, but my heart tells me that at this point, we're learning a process and we should embrace the process. So sorry, but there's a process. I don't want an answer. I want a process. So what do you think we should do? Multiply the top and the bottom both by. Nice job. So you went a different route than I thought you might, but I'm actually okay. I like this. So good job. So what do we get on top? We get 6 roots of 28. And what do we get on bottom? We get 28. And of course, if you do this the way we have, what can the 6 and the 28 both be reduced by? Divide them both by 2, right? And so you wind up with this answer. And because you're going to do this assignment in Delta Math, if you do this and hit submit, it's going to say your answer is incorrect. You have 1 attempt remaining. Do you want to take a guess as to why it's wrong? We didn't do anything wrong, but it's wrong. Right. And so I like the pathway that you chose by having me do what we did, but do know that a lot of times at the end, you're going to be stuck with a radical up here that then himself needs to be reduced. So let's head down over here. How do we break down the square root of 28?
14 and 2.
I don't like 14 and 2 because neither one of them is rootable. I do love 4 and 7 though, right? And so it breaks down into 2 roots of 7. Do we agree? So the answer, the top, is now 3 times 2 roots of 7.
How can
Go ahead, Sam. Go ahead, Sam. Keep going.
it is 7 is the same answer as 28, right?
That's so much of what we're doing today is we're honestly just cleaning house. We're simplifying things. The top is now 6 roots of 7 and the bottom is still 14. Are you okay?
Yeah, I thought you were reducing the top to 3 now.
Kale, do you see where this 3 came from with the red arrow pointing to it? Okay, it was this 6 up here. I'm circling it in red right now. And I reduced it by dividing it by 2. Because I could also divide the 28 on the bottom by 2. And that's just fraction reducing 101. If you can divide things on the top and the bottom both by 2, you divide them both by 2. And that's where the 3 came from that I'm pointing to yet again with a red arrow. So let me ask you again, do you know where just this 3 came from? Okay. Let me ask you another question. I'm going to switch to the color blue because there's none of that up here. Do you see where this blue box came from?
Absolutely. You broke it down.
I did. I broke down this blue oval up here. Good job, Kale. You and I. How do I know how to break it down?
No, like, how do you like that answer?
Are you talking calculator?
No.
Oh, how do I know? Because my job and your job is to look at something like a square root of 28, because we've done a lot of this, and just to know that 28's not done. Like 28 is you just know because you've done hundreds of these. Can't simplify, right? So the first 3 examples, we had roots that couldn't break down anymore. Does that help?
Yeah.
You better? You sure?
Yeah.
Let me ask you one more question, Kale. Yellow box, do you know where this 6 came from? Attaboy. So those 3 and 2 made the 6. Does anyone else have any lingering questions about where things are? Awesome. So the last step, now that we've fixed the bottom, simplified the top, is of course to reduce the fraction. And you realize now, here comes another one of those diagonal red boxes. Can those 2 numbers be reduced?
Yeah.
Nice job. So our final answer is going to be 3 root 7 over 7. Do you still think this is as easy as you did like 5 minutes ago? I'm just asking. I'm not asking a challenging question. I'm just curious to know where you are. Okay, let's do one more and see how you do. Let's do 10 over the square root of 80. Would you guys like to try one without my assistance? You scared? Scaredy chicken, Sammy? Brycey, what are we going to multiply by here? Nice job. And what are we going to get on the top, Bryce? Good man. And what are we going to get on the bottom, Bryce? Okay, great. So step one is completely done. Like that's the meat and potatoes of what we're doing today is can you fix the bottom? So we can say bottom fixed, check that off our list. But now there's some work to do. Kind of like that last problem. I got some stuff. What are you thinking, Chance? Absolutely. And by the way, that's not what I was thinking he might say, but there is no harm in reducing 10 and 80 right now. Do you notice anything else though that we're going to have to do? Right. But hey, listen, no harm, no foul. It's kind of like doing a little cleaning before you do the next cleaning. Like if you do a little first, then there's less to do. I'm down, Chance. So let's go ahead and try this a little out of order. I love it. What can 10 and 80 both be divided by? By 10, leaving this answer right here. 1 root 80 over 8. And then you guys nailed it. Let's head off to the side. Let's break this down.
80 is 5 or 4 over 5 because total is equal.
This is a death number that we break. Anything that involves the number 16 is going to be a death number. 16 times 5 makes 80. And what's the square root of 16? Good. So what we're going to do now is we're going to re-inject 4 root 5 as the new top of the fraction. It's going to go back up to the top. So we're going to have 4 roots of 5 over 8.
So say we have a number. You want me to put in front of that?
Great.
How would you write that?
If there had been let me write it in blue, okay? Just follow. Are you talking right there where I just wrote in blue?
Yeah. Say there was a number in front and you still had the 4 root 5 reduced in space.
No, this 4 that I'm writing in blue and this 4 that I'm circling in blue, they would find and multiply each other. They would make 16. Okay?
What I'm saying is like, so you have this 4 root 5, right?
Mm-hmm.
Let's say that 10 that was 11.
Are you talking about my blue number up here?
Yeah, so say you had that extra number. Do you ever have that extra number?
Yes. In fact, let me finish this problem real quick, because when things like this happen, then someone's finally just about to get it, and then we do this, and then they go, crap, let's come back, okay? Let me finish, and then I'll come back. Deal? Okay, so let's get back to this before Sam asked that hypothetical. These two numbers, thank you, Kelton. These two numbers in this golden box can both be divided by 4, right? And so finally, we're going to wind up with a 1 and a 2, and our final answer is root 5 over 2. Are we okay with that? Now, if you like that, then ignore what I'm about to say. I'm going to try to answer Sam's question, and I'm going to do it as quickly as I can. And Sam's question is, Sam's question is more pertinent if we didn't do what Chance said to do. So I'm going to go back up now and write some stuff. You're welcome to come along for the ride on this. Do you remember, I think it was Chance that told us we should reduce the 10 and the 80? Let's say we didn't do that. Sam, this is absolutely the best way I can answer your question, so please stay with me, okay? Listen as hard as you can. If I now take this blue square root of 80 and I go off to the side and I break it down, I break it into root 16 and root 5, right? And I get 4 roots of 5.
Yeah.
So now follow along. If this blue oval goes back up and replaces the other blue oval, the top of this fraction will say 10 times 4 root 5. They multiply. That's what I said a few minutes ago. Yes, they multiply. So then you see how the 10 and the 4 make 40? So you wind up with 40 root 5 over 80. But then at the end, when you reduce it, you still get that. You follow?
Yeah.
You guys think you could do some of these?
Yeah, because you're still putting.
Yeah, like it's all going to come out in the wash, I think, is the expression that I've used before. So you guys think you got this?
Yeah.
Okay. So don't worry, there'll be plenty of time. I